Everyone is talking about lithium, cobalt, copper especially. It's hard to mine, it's hard to find. Hasn't been any new exploration in anywhere else for the last 10, 20 years. The amount of platinum that we mined and we produced in the entire history of humankind, it can fit in this room.
Let's face it, the mechanical properties of palladium as a conductor, and it's wonderful.
The behavior is really similar to gold if you use it in printed circuit boards. But now with the prices that we see on the palladium, I believe it opens up some opportunity for other applications.
Wait, say that again as percentage?
Yeah, 9.9999% of the rock that you are mining is waste.
And you have to move a ton of material to recover one gram. Do we have enough copper for the coming AI data centers?
Welcome to the IPMI's 50th annual conference. And our guest here with us today is Mr. Mohammad Doostmohammadi, the founder and CEO of PH7 Technologies. How are you doing today?
Doing well, thanks. Hello, everyone.
Yeah, welcome.
Thank you so much for having me here.
Thanks for coming back.
Yeah,
it's been a bit.
Yeah, it's been a bit, and I had a great experience last time, and I believe it's going to be another great experience this time.
I was going to ask you, Mohammad, I was thinking about palladium drivers and demand. It's one of the strong PGMs, and we've seen a tremendous amount of demand over the years coming out of auto catalyst. What about the future? Do you think we'll see some more electronics or AI data center demand coming in the future? Or what are your thoughts?
A great question, actually. And, palladium has been majority of the palladium is going to AutoCADs, and there is a concern that AutoCADs are going down, so the demand is going down as well. What's going to happen to palladium? But now with the prices that we see on the palladium, I believe it opens up some opportunity for other applications. Printed circuit boards, traditionally they had gold and silver, and then at some point palladium has been added to them as well because it has a great resistance and anti-corrosion behavior of the palladium, as well as a great conductor.
Great conductor.
So it's right now with these gold prices, I believe for the last 20 years, all the PCB manufacturers tried to get away from gold, but they couldn't. And the gold price is going higher and higher and higher. Now palladium prices are actually very interesting and exciting. And you need more and more of these printed circuit boards to be produced every year, the chips and everything. And I believe palladium can be an interesting metal to look at it for the future.
Well, there's certainly a significant variance in price between gold and palladium.
Exactly.
In this market, and that's probably what the manufacturers are looking at.
Exactly.
And let's face it, the mechanical properties of palladium as a conductor, and it's wonderful.
It is. It's actually the behavior is really similar to gold if you use it in printed circuit boards. There are some concern about the manufacturing of the PCBs, change it from gold to palladium. Something is already happening, but to make that change, I believe the planning needs to happen. And I believe it's happening because exactly the driver is that price difference.
And they're always looking at the price difference.
Always. The world's most important metals nobody knows about. Why are PGMs absent from the mainstream discussions about critical minerals? What's your take on that?
Yeah, so PGM is one of the metals that's very rare. You can't find it easily. And there is not much PGM, platinum, palladium, rhodium, iridium, ruthenium in the earth that you can mine. You have limited resources, very limited resources. More than 70-80% of these metals are in South Africa. So it's coming from the mines over there, some in Russia and some in Zimbabwe. And
all legacy mines.
Yeah, and it's hard to mine, it's hard to find, and hasn't been any new exploration in anywhere else for the last 10, 20 years. Very rare, very scarce metals. But if you look at the critical minerals, critical metals, everyone is talking about lithium, cobalt, copper especially.
Always copper, right?
Yeah. However, I believe PGM deserves to be named as a critical metal. It's really it's a driver for a lot of things. So you look at the environmental catalysts. It's all working on PGMs. You look at this printed circuit boards, Palladium is actually playing an important role. And there is thousands of applications that no one knows.
Industrial.
Yeah.
No one knows. No one knows about it. I believe PGM hasn't, the whole PGM industry hasn't been doing a great job in marketing. Just marketing, as I mean, is not industry B2B, B2C, just people.
Right.
Just bring the awareness of how rare these metals, how precious these metals, how important these metals. And as an industry, we need to do a better job to bring awareness of PGM. Sometimes even, that was a panel this morning. We're talking about anodes, MMO anodes, multi-metal oxide, which is mixing ruthenium, iridium, expensive materials. And it has been priced based on the titanium, not based on the coating. And you sell it, no one actually even think about recycling it or having it back.
Wow.
They don't know the value. They don't know how rare these metals. They don't know actually bottleneck for hydrogen is iridium.
Right.
No one recycling it. Look
That's
at the
right.
spark plugs.
That's right.
Spark plugs is no one even care about recycling it.
Same
No one
thing.
knows about the value.
Hey guys, did you know there's value in those used spark plugs you're changing on a daily basis? Yes, used spark plugs. The spark plugs that have value are platinum and iridium spark plugs. Copper plugs have zero recycling value. But you guys are doing this on the daily. Might as well get paid for them. To get pricing, just click on the link in the description below.
So I believe it's just this awareness that doesn't happen in the industry.
Yeah.
Investors, bankers, we need to, and just people, how much of their life is depending on these critical metals and these PGMs, and it needs to happen.
Yeah, you bring up a really good point, how rare they are. Just how rare are PGMs compared to gold, silver, or copper?
So just imagine this, the amount of platinum that we mined and we produced in the entire history of humankind. It can fit in this room. That's the whole platinum.
This is not a very large room.
Yeah, that's literally, that's how much platinum we mined.
Wow.
The platinum is, that's very rare. It's being used in grams in applications, milligrams in applications, ppm in applications, but you have limited amount of platinum. And the grade of the ores are going lower. I know, well, you're talking
So
about
why
a couple
are they
of
so
grams
hard
per
to
ton.
find and process?
It's on the exploration side, they are only occurring in very special circumstances that you can find them in, and that happened in South Africa, that you have those materials. But the problem is that they are not really concentrated in one place. So that's a major problem. I mean, you're talking about gram per ton. And it's just imagine 99.999% of the rock is waste. Only that's
Wait,
one
say
ppm.
that again as percentage?
Yeah,
Say that again.
9.9999% of the rock that you are mining is waste.
Wow.
And only 1 gram per ton.
One
1
gram?
part per million.
You want to know? Yeah, I was just going to go there. The way my mind thinks is mathematically, if it's 2 parts per million, it's
Correct.
2 out of 1 million parts.
Wow.
So it's 2 parts out of 1 or 1 part out of 1 million
Parts. That's insane.
That's
and you need
insane.
to process it. You need to
Right.
extract it. You need to
And
concentrate
you have to
it.
move
You
a
need to
ton of
Yeah.
material to recover 1
1
gram
1 gram.
1 gram.
Wow.
from a ton. Oh, that's crazy.
So we're
That's
talking about
very
copper
interesting.
as a base metal, which is a critical metal.
Right.
That copper is 0.5%. 1% of the ore is copper. But when you go to PGM, that's what. And PGM is a basket. It's not only one metal that is 1 gram per ton or 2 grams per ton.
Right.
It's a mix of platinum, palladium, rhodium, iridium, and all
Together.
of that. Together, you
That's
get there.
1 to 2
Wow.
grams.
And then you want to separate it. Downstream processing is complex and complicated. And overall, these PGMs are very resistant to corrosion, which is the way the metallurgy works. And dissolving them into the solution, it takes time. And the time that you mine them to the time that you refine them and having it in the market, we're talking about 6 months to 1 year. That's kind of the supply chain that we are talking about. And it adds on the scarcity of these metals. The processing is not easy as well. And that's overall supply chain of PGM, platinum group metals, has been it's a well-established business. And players are doing a great job, but I believe this awareness of how rare, how hard to extract these metals and having it
Okay,
in the
so
market,
let's speak
that's
to
gonna be
that
important.
because that's kind of a mind-blowing concept. As an everyday individual consumer, how would I interact with PGMs on a daily basis?
Yeah, it's a great point. And you see them everywhere. So you bring your phone, laptop, there's palladium in there. Absolutely, you have ppm of palladium in your phone. You have your cars, catalytic converters. You're running in grams of PGM in your cars, and they are very important because without them, the air quality that we have right now is impossible.
Right.
Stationary, the same thing, stationary diesel generators and all of that.
Diesel
They
generators,
need
yeah.
it. They need it. Without that, it's going to be the
Well, if you go back
trucks,
to the cars
diesel.
for a second, I think about, okay, the spark plugs in your cars have platinum and iridium. Those are PGMs. But your entertainment system
Correct.
has circuit boards in them. In your dashboard, there's PGMs in there. How about the airbag? You have 6, 7 airbags surrounding you in a vehicle, and there's a thin platinum wire in there as the
Correct.
trigger. So we interact with PGMs on a daily basis, and we don't even realize it.
No one knows.
Yeah.
No one knows.
No one knows.
It's in the dental field.
Everywhere.
Right?
Everywhere. It's just
Yeah.
you call it, and then jewelry is another
Jewelry,
application. Maybe a little bit
absolutely.
awareness over there,
Yeah.
but not much.
Not
It's
much.
mostly you see it in South Asia as a replacement. And for investment, it's another great opportunity that hasn't been talked a lot about that. I believe that awareness of PGM overall, that's going to be a great opportunity.
And where I want to ask, for the viewers, can you give us a brief background with the plethora of knowledge you have in the mining and PGMs?
Personal background?
Your personal background?
Yeah, so I'm a mining engineer and a chemical engineer as well. So kind of mix of chemical engineer and mining engineer together. It got me into mineral processing and metallurgical extraction of different type of metals. I started my career from gold mining, which is another interesting subject, I believe, for the next time. And from gold mining and mineral processing, wastewater management, cyanide management, and all of that.
I always love talking about gold mining. That's one of my things.
It's one of the interesting
Always.
subjects.
Yes.
And then I started, I've been in PGM business in about 6-7 years for now, and focusing on recycling side. And now we are seeing some opportunity in the mining as well. So
Excellent.
That's very interesting on the recycling. We're talking about low-grade materials, and low-grade is about 1,000 ppm in recycling. So you go to 2,000, 3,000. The grades are getting better.
Yeah.
And you're talking about mining concentrate, which is the highest grade of material coming out of the mine. You're talking about 50 ppm, 100 ppm,
That's
150
right.
ppm.
That's low.
At the mine.
That's very
But
low
it's a
compared to
primary
recycling.
mine.
Right.
Yeah, and it's a very interesting opportunity. We believe that it's something that we can investigate in the future as well.
So what technologies would stop working without PGMs?
I would say all the they are everywhere in the whole supply chain. You see this PG. Just look at this AI and data centers. That was your question and opening of that.
Right.
It's the chips manufacturing is relying of these nanometer wires.
They're
That can
small.
be impossible with PGM. Be impossible with PGM. So in manufacturing, and then oil and gas is another example that so oil and gas, not only the fuel that you use for your car, it has hundreds of different products, and those products are coming through different type of chemical reactions.
So a lot of industries are dependent on PGMs.
They are. So
Petroleum industry?
industry is
we
a
wouldn't have
huge
that
one.
otherwise.
Impossible
Oh, yeah.
without. So you have all of the catalysts. Most of the catalysts in petroleum industry is coming from PGM. So you have platinum, iridium, hydrogen,
Exactly.
Oh, yeah.
fuel cells,
Right.
Exactly.
and chlorine-alkali electrolyzers, chlorine producers, all of that without PGM. Glass manufacturing is another good example of that. It's all of these are relying on PGM, platinum, palladium, rhodium, different PGM that you have in the market.
Big
When
industries
you
then.
look
Yeah.
at the periodic table of elements and you see the cluster in the center of the 6 PGMs, what makes them so unique chemically? What are those properties that make them unique compared to the rest of the table?
So they have actually some unique, amazing behavior overall that they can have a lot of application. One of them is their resistance to harsh environments.
Corrosion.
So corrosion,
That's important.
They don't corrode. So
Yeah.
that's why the processing is hard as well, because processing is kind of accelerated corrosion that you do.
You have to corrode.
Corrode it so fast to be able to process it, and they don't corrode.
And they don't corrode.
Right.
So that's one of the best applications. So you see the thin films, you see on the plating side, you see on the hydrogen, you're using it as an MMO for the anode, which is a very harsh environment that they survive for 8 years sometimes.
But can't we use cheaper materials for the same applications?
You can, but you don't get the same outcome.
You don't get
The same efficiency that you have.
You
The
don't
same,
have the efficiency. It doesn't last as long.
not even close to that. Not even close to that. Then your maintenance and OPEX and operational cost is going to go higher
And
and
manufacturing
higher.
cost.
All of that is going to be higher. So if you use, for example, replacing PGM with base metal as a catalyst, we look at PGM at 10 years of turnaround and the maintenance. If you want to do the same thing with base metals, you have to replace them every 6 months. So at the end, your operational cost and the shutdown that you have and the maintenance cost that you have is going to be way higher than using the expensive PGM, that the CapEx was there higher, but operation was, it makes a lot of sense.
So that's what makes them chemically unique then.
Chemically unique, and they are conductive as well. So
Yeah.
that's another great application that they have. They're actually pretty good, really good, and that's why you use it on the surface of the anode, for example. You use it on the plating of the printed circuit board. So there is a lot of special character that they have that is make them unique for applications. Another one is the melting point. So some of them has higher melting point that actually going to be good in. Some of the applications are crucible. So there is depending on the industry, these metals are providing different type of unique character that you can use it.
Well, Mohammad, when PH7 Technologies began business, you were focused on recycling of secondary PGM materials. Now we understand that you are looking to expand into the primary mining segment, I guess primarily copper. Can you talk about that a little bit?
Yeah, of course. So PGM has been an amazing, I believe, pathway for us because we proved the technology can work with the hardest materials that can be processed.
And you did.
So we did that. We scaled it up. We have our commercial plant operational in Vancouver. And now we are adding different metals to our portfolio. And we really like to go to mining applications because of it's a different market, but it's the volumes.
Yeah.
And it's how big is the market, the primary market especially. And we can help our mining partners to increase their efficiency, increase their recovery.
But that would be more in situ on their
side. Absolutely.
On their site.
Absolutely.
Yeah.
Because you cannot ship ores around the board because
you gotta
they're
be
low
there
grade. It doesn't make
physically
sense
on
economically on recycling because of the grade and it's high grade. So you can ship it to our facility, we can process it, and it can go around the world. But you cannot move rocks around the world.
No,
There is
not
no,
That's tough, huh?
It doesn't make sense.
No, you have to do it in place.
Economically, you have to
So
be there.
that's why we designed this process, and it's a modular process that we bring it to the mine sites, and we help our mining partners to extract the copper, which is one of the materials that we see in the future is going to see a huge market deficit because supply is going down and demand is going high. So right now we have 24 million tons of copper as supply. And it's predicted that by 2035, we're going to see about 40 million tons demand for the copper.
Is that right? Wow.
But that $24 million supply is actually not going to stay at 24 million. It's actually going down to 16 million.
Really?
So the gap is getting larger and
Larger.
larger.
Yep.
The grade of the
The
ores are going
second
lower.
question I wrote down was, do we have enough copper for the coming AI data centers?
That would be a no.
That's a no. That's literally
no.
right
Right.
now. That's a no.
That's a no.
It's you see all the forecasts for the copper. Everyone is so scared. So just to give you an idea, we need 40 million kilometers of new copper cables and wires. 40 million kilometers for the data centers that is approved right now.
Proposed to
Right now.
be built.
Not the future.
They're approved,
Not the future.
but they're obviously not
Yeah,
in
you need 40 million
construction.
nucleus. And then you have all the electrifications that is happening. You have all of these. Where do you want to find that copper? The ore grades are, as you know, is going lower. It used to be 1.2%.
It's going
right
down,
now we
huh?
are seeing average of 0.7%. In next 10 years, it's going to be 0.5%.
Wow.
So that's why we really focused on copper, and we believe that it's a huge market for us because we can help our mining partners to extract from what they already mined.
That's
so
a great
the first
opportunity.
question that I wrote down, which will be the last question that I'm going to ask, is are we going to see any new PH7 production facilities for secondary recovery materials outside of Canada here in the near future? And when I say near future, 3 to 5 years.
Yeah.
Right?
The answer is yes. And the reason is that we want to build more of these plants around the world because of all these geopolitical issues, the movement of these materials, the ban you see in the export of the materials. So we bring our processing facilities closer to the supply. So we're thinking about absolutely US as a great neighbor for us. Lots of materials are already coming from the US to us. It's better to build it over there. So that's already on the plan. And eventually around the world, going to South America, Africa, South Asia, Middle East.
A lot of talk right now about strategic status of PGMs country by country. It's almost as if trade barriers are going to be going up in the future. And countries are trying to identify a source of supply within their borders and keep them within their industries. And I think that's an opportunity.
That's an opportunity for us because we can build it over there instead of just having a centralized operation. Like some of our competitors, they have to be centralized. They don't have option to be modular and build it around the world. Right. So we have the option to build it closer to the supply and keep the supply chain in the country as it's happening right now. The countries are actually, they want to keep it over there.
That's good. Well, it's exciting to see where PH7 has gone in the past and where it's going in the future.
Absolutely.
This is it's great always to have you back and to bring us up to speed.
Absolutely. It's a pleasure to be here. Noble 6 team has been an amazing partner for us. Looking forward to the future.
Thank you.
Thank you, Mohammad.
Thank you.